Hi dear students, welcome to my session. In our previous session we discussed about star and delta, problems on star and delta to star transformations. In this session we will discuss few more problems on the same combination, star to delta, delta to star. Let me solve few problems. I took it from other from net. Just follow my PDF. Then we will solve few problems based on the examples. Just right. Let me move to the first problem. L is equals to, find the value of voltage source Vs the delivers 2 amps current through the circuit shown in figure. So by this is the applications of star to delta, delta to star. In this application we will solve as many problems as we can. So please concentrate here. So here the find this value of voltage source. Let me see the circuit. So this is a circuit. In the circuit we are going to be find the value of voltage source. This value we are going to be find. He given this all the values. I is equals to 2 amps, and he given the all the values of resistances. All the values of resistances are most probably 1 ohms, and few of the 2 ohms, and rest of them are 0.5 and 3 ohms. So based on this arrangement we are going to find the voltage source. Let me summarize the procedure. How to find the voltage source? If you know the values of, if you know the which values only, then only you can find the voltage source. You should know first, you should know voltage. Wait, first you should know for the writing of voltage, V is equals to IR. V is equals to IR. Wait. V is equals to I and R. From here you can find the voltage. If you know the value of current, and if you know the value of resistance, then you can find the value of voltage. Here you know the value of current, 2 amps. And where is the value of resistance? For the finding of resistance value, you need to be find this entire resistance, that is nothing but a R equivalent. You need to be find the R equivalent value from this circuit. Hope it clear. So now your job need to be find the value of resistance of this complete circuit. For that, for the finding of equivalent resistance of this highlighted part, you can use any reduction technique, either maybe star, either from first we used to follow from series, then parallel. If series and parallel is not possible, then we are going to be apply star to delta, delta to star transformation techniques. From here, is there any possibility for series or parallel? Let me see. Here this is not series, this is not parallel, but this is series because same value of current is flowing through this, and this is series. And one more, right, that's it. This 2 are series, and this is 2 are parallel. This is 2 are series. Then the value will become a 3, right? Now after redrawing this is 3. After redrawing this 3 ohms, right? After redrawing the 3 ohms, let me take highlighted part. Let's edit. So after highlighting this, let me change my tool. Sorry. So, let me use this marker itself, because is there any other tools for this highlighting parts? Please display zoom window, view edit. There is no other option. We are going to be use this tool itself only. So let me go for this. So this is 2 plus 1, 3. Here there is a 3 ohms is there. Instead of writing 3 ohms, it means 3, 1 and 1. These are 3 are look like parallel, right? For better understanding, let me open the new slide. Then you can able to understand what I'm trying to say. Let me open Paint. Right. It's clear. Now let me add this. Let me compare these two equations. From this circuit, you are going to be addition of this part 2 plus 1 is nothing but a 3. You are going to be adding up this 2, means it will become a 2 plus 1 is nothing but a 3. Then it will become 3. This is 3 ohms, right? Then this is already the value of resistance is there. This is 1 ohm. Then whatever this is also 1 ohm. This is 3 ohms, right? This is 1 ohm. This is 1 ohm. From this, you did this. You completed only A, B, D, C. The part name is called A, B, D, C. This center of the part. So you are converting this delta into star. Again, one more delta is there. We will look further, but timing you should consider this only first. First, you need to be convert this delta to star. For that, I'm going to be drawing the star connection between this. So now this is star, right? Now this is star. I can make this star point is nothing but is 0. What is this point? This point is A. This point is D. This point is C. So now you are converting delta to star. For the converting of delta to star, you should remember this formula. 3 into 1 by you should multiply the adjacent arms by addition of the total arms. 3 into 1 by 5. Then the value will be here. The value already is given. 3 into 1 by 3 into 1 by 5. Then the value will be 0.6. Here the value is given 0.6. Then this value will be 0.6. Then this value will be 1 into 1 by 5. The value will be 0.2. 0.2 and this value will be 0.6. Right? I think you done with this. You done with this. Instead of 3 ohms, 3 and 1 1, you are converted delta to star. Now draw this rest of the part. How this rest of the part look like, right? Let me draw this part as it is. Let me add my black color. This is 1 ohm, right? This is 1 ohm, and this is, instead of writing 1 ohm, I'm going to be writing directly 1, because 1 ohm is occupying a very large space for me. So this is 1 ohm. So now what about this? This is 3 ohms, 3, 9. What about this value? 3.5, 0.5. This is series, right? 0.5 and 0.5. This is 1. Instead of writing that, you can write this. I am adding those value is nothing but a 1 ohm. 0.5 and 0.5 both are in series, so that is the reason I'm writing 1 ohm. This is 3 ohms. Hope it clear. Now from this circuit, this look like a delta. It's not series, it's not parallel, because already you did for the series. From this here, they already it's a series you mentioned. From this series, you got a circuit like a delta. Now you're converting delta to star. From this, so now I'm making star connection of this branch. Sorry. So what are the points? Points are E, F, E, F, and G. This is point G. Now let me do apply delta to star transformation. 3 into 1 by 5. It means 3 into 1 by 5. 0.6. This is 0.6. Next, 3 into 1 by 5. Next, 3 into 1 by again 5. Same 0.6. Next, 1 into 1 by 5. It's nothing but a 0.2. Now you converted delta to star. Whatever the previous circuit, then there is a one circuit is there for the 1 ohm, 5 ohms. Let me draw the circuit itself. One, this 5 ohms is, sorry, not 5. How much value? This is 1 ohm. 1 ohm is connected here. This is 1 ohm. Next, and across that there is a battery is there. Sorry. Point. This is plus and minus. Current flowing through this 2 amps. Right. Same. Now let me erase this delta connection. Let me erase that delta connection. Because you converted delta to star, right? Then delta is not needed here. So that is the reason I am erasing the delta connection. See, look at carefully. I am erasing only delta connection, which is in black shade. Next, I am erasing the delta connection here in this part. 0. Right. Now observe the circuit carefully. So you need to be remove this also. I forgot to remove, let me remove that also. Right. Now I removed the all the delta, then I highlighted the only star connection. So here observe this connection carefully. Here observe this connection carefully. Here 0.6 from this is 0.6. This is 0.6, 0.6, 0.2, 0.6, 0.6, 0.2. This is a node of 0. This is node of 0 again. Common node. I can say neutral also. Here if you observe this complete circuit like this, this complete circuit from here to here, from here to here, from here to here, 0.2 ohms, 1 ohms and 0.6. Here are 3 are in series. From here, from O to O, I can say this O or O dash, O dash. So he is mentioned O dash. From O to O dash, we have two parallel circuits. In the parallel circuits, there is a series circuits are there. Here, this 1, 2, 3. These 3 resistors are connected in series, and 0.6, 1 and 0.2 are connected in series. After the resulting after adding up the series will be parallel to this adjacent arms. Hence, O dash will be like this. O dash will be like this. What about this value? 0.2 plus 1, 1.2, 1.2 plus 0.6, 1.8. The value is 1.8. This is 1.6 plus 1, 1.6, 1.6.2, 1.8, again 1.8. Hence, the parallel connection will be O dash will be 1.8 by 2 is nothing but a parallel connection 0.9. This is the value of the resistance between O and O dash. Hope you understand what I'm trying to say. Here, it look like completely same, right? Whatever we did same thing. So hence it will be 0.9. Now after the resulting of 0.9, I'm going to be erasing of this 0.9 like this. Let me see. I'm going to be erase this part, this complete part, by representing my new value. What is my new value? My new value will be between O dash. My new value will be, this is O, let me write, this is O dash. The new value will be between O dash will be, this is 0.9. This is 0.9. Hope you on the line, right? So here the 0.9 plus 0.6 plus 0.6. Hence the value will be how much? These 3 are look like in series. 0.6, 0.9 plus 0.6. Hence the value will be 2.1. Value will be 3.1, 0.6, 0.9, 0.6. It's not 0.6. It will be 0.6. 0.6 plus 0.6 plus 0.9. It will be 3.1. The value will be 3.1 of this complete value of resistance between A and G. I am going to be redraw the circuit by removing this. By removing this, the value will be 0.6 plus 0.1, 0.6 plus 0.6 plus 0.9. then the value will be 2.1 ohms. 2.1 ohms. This is wrong because 0.6 plus this value will be 0.6. This entire value will be 0.9. Then 0.9 plus 0.6 plus this some errors may be there in this PDF file. Don't follow those errors. Please try to rectify those errors. So the answer will be 2.1. The answer will be 2.1 ohms. 2.1 ohms between A and G. Where is A and G? This is A. This is G. Where is it? This is G. Between A and G, total value of resistance between A and G is how much? 2.1 ohm. Just 2.1 ohm. Hope you clear. So the total value of resistance between A and G is 2.1 ohms. Hence, now you know the value of current and you know the value of resistance. Now your duty need to be find the how much voltage source is there. For that, you know the formula V is equals to I multiply with R. What is I? I is nothing but here 2 amps already is given, and R is nothing but a 2.1. Then 2.1 into 2 is nothing but a 4.2. The voltage of this battery is 4.2 volts. 4.2 volts. This is the way of doing this problem. For this is my side of solving of this problem. Let me see in the document. In the document, he drawn so many circuits. While the solving this problem, he drawn so many circuits in theoretical way. He write lot of things. Try to focus on that. Then let me read this document carefully. For this, he written clearly, convert the 3 terminals delta connected delta networks. One is ACD, and another one is EFG. This is EFG. G. Right. One more, ACD. So this is one network. This is one more network. For this network, you are doing delta connection, right? So like this. So in theoretically, he wrote clearly. So into an equivalent delta connected network, consider the delta network ACD and the corresponding equivalent delta star connectors resistors values are given as. So here this is the way of solving the problem. Here the RAO you need to be mentioned. Delta to star, you can mention RAO, or instead of mentioning RAO, you can write directly RA. You can write directly RA. You can write directly RA. So next, RC is nothing but a same types of representing. From here, he wrote directly instead of RAB, RBC, RCA, he wrote directly 3 plus 1 plus 1. Instead of writing 3 plus 1 plus 1 plus 1, he wrote directly 5. Then 3 by 5 is nothing but a 0.6. RC, RD. So like this, you are going to be finding the delta star connected networks. After that, you need to be concentrated on the second delta network, that is EFG. From this network EFG, the equivalent resistance delta is converted to the star again. Just look at this circuit. Sorry, just look at the calculations. From this, here instead of mentioning IE, RG, we can instead of mentioning REO dash, we can mention directly RE, RG, RF. For this same formula, adjacent arms by some summation of total arms, same, then you will get similar values because the arms are same. Now the original circuit is redrawing after the transformation. After this transformation, we redrawn again in the PPT in paint format. Here also please try to observe here. And further simplified the applying series parallel combination. For the applying of series parallel combination, I redrawn. Just I redrawn the circuit to apply the series and parallel combination. After the redrawing circuit, the circuit is very clear way of understanding. You can easily find which is series, which is parallel after redrawing the circuit. And this is O and O dash. Then from this O and O dash, you are going to be summarizing of this circuit again. Just let me move to the next slide. From this O and O dash, I converted this O and O dash, this circuit. Wait, this circuit. This O and O dash, I converted to the 0.9 ohms. How I means 0.2, 1 and 0.6 are both are series. These three are series. These three are series. After the resulting of the series is look like a parallel. After the parallel connection, after doing the mathematical things, then the value will be 0.9 ohms. Then I substitute the 0.9 ohms between O and O dash. These points are very important. You should remember these points. These points are very important. O dash, all these points. Then based on this O and O dash, already you know 0.6 and this also 0.6. This is wrong. Instead of writing this is wrong, you should write 0.6. Some errors may be happen. This is 0.6 ohms. This is 0.6 and 0.6 plus 0.6 plus 0.9. Then this is also wrong. Instead of 3.1, it should be 2.1. The value will be 2.1 ohms. So here sometimes 2.1 ohms. It's not 3.1, it's 2.1. Then you know the value of current and you know the value of resistance. Then you can find the value of voltage. 2.1, it's not 3.2, it's a, right, it's a 3.2 only because we need to be add 1, right? So it's correct. Let me see. 2.1 plus, sorry, I think I'm wrong. Here you need to be add this resistance also. Hence the total resistance R equivalent is, instead of 2.1, you need to be right 3.1. Sorry, 3.1. Correct. It's not wrong. This is wrong. This is 0.6. This is 0.6. After adding this all 4, then it will become a 3.1. Right. If you're writing this only this across this A and G, it will be 2.1. If you're adding this 2.1 with 1, it will be 3.1. Then 2.1 plus 2, it will be 3.1. 3.1 into and you know the resistance and you know the current, then it will be 6.2. The voltage across this resistive element is called 6.2 ohms. 6.2 ohms. Sorry, 6.2 volts. Right. After the multiplying, so you need to be use these types of wordings. Then it will be looks very clear. The source voltage source, the source Vs that delivers 2 amps current through the circuit can be obtained as Vs is equals to I into R. R is nothing but a R equivalent, total equivalent resistance of the circuit across from this this to this, from this point to this point, it will be 6.2. So this is way of solving the problems in star to delta, delta to star conversions. Now let me see next problem. For this problem, this is a very important problem and most repeated in the examination point of view, especially in competitive field. So determine the equivalent resistance between terminals A and B. So here this is A, this is B, this is B. So this is A and this is B. So you need to be find the resistance between A and B. How you are going to be finding? That is point here. For the making arrangement of A and B, is there any series and parallel on the circuit? This between let me check between C and B. There is no series A element. All are some interlinked to some other point. There is no series. There is no delta because the point is here. This is delta formation is there, but there is no use of transferring this delta. Again, here one more delta is there. But here instead of doing this two deltas, but here the middle one is look like a star. So let me convert this star to delta. Then the circuit is very easy, right? Hope you clear. So instead of doing this, sorry, instead of doing these two deltas, I am doing this one conversion, star to delta. So star, this is star, I'm converting to delta. After the conversion, these two parallel, again these two are parallel. Then this circuit is look like, after doing parallel, this the rest of this resistance is look like a parallel. So something we can do some little bit sorting up about by applying this delta to star conversion. Let me apply delta to star, right? After applying delta to star, this is the circuit we will get. Earlier the circuit is look like this. Let me redraw that. Earlier the circuit is right. This is a circuit already we know. From here, this is the value is 2, 3, 4. This is value 2. This value is 3. This value will be 4. Just imagine this is a 2, 3, 4. From this 2, 3, 4, we converted into the 6.5, 8.6 is 8.6. After redrawing that, just we applied the star to delta conversion. Star to delta is nothing but a, we need to be at the adjacent arms. Means if you know the, if you are finding RAB means RA plus RB plus RA into RB by RC, like that. If you're finding RBC means RB plus RC plus RB into RC by RA, like that. So just write this 2 plus 4 plus 2 into 4 by 3, like this, for the finding of this value. For the finding of this value, 2 plus 4 plus 2 into 4 by 3. For the finding of this value, 2 plus 3 plus 2 into 3 by 4. For the finding of this value, 4 plus 3 plus 4 into 3 by 2. Same we are writing. After that you will get, then from here this both are parallel. 3 into 8.66, 13 into 1. See, look at here carefully. Look at here, look at here. This both are parallel, right? Then after that I redraw the circuit like 2.33. From here, .5 ohms. This delta is converted to again star. This is delta, right? if you make this connection from here outside, so you can make that is delta. This is delta connection. 4 2 3 from here delta I converted to star. So this is lengthy circuit. You guys need to be do from by drawing the more circuits, then it will be very clear for you guys. Let me move to the paint software, then it will be better for us to write this equation very clearly. Let me move to the paint. Right. From here, already you know this circuit, right? You know how we got this circuit. Let me draw the circuit, or let me take this circuit screenshot. Let me use this screenshot. Right. From here, let me draw. As you know, before this delta in our problem star. Now we converted that star to delta. This is new circuit, means modified circuit, right? Again, is there any delta or star? Right here there is no delta because these two are parallel. Let me draw. These are two are parallel, sorry. Right, these are two are parallel. Again, these two are parallel. What about this? What about this and this 6.5 and 2? I'm going to be redraw like this. I'm going to be redraw. This is my A point, right? And again, I'm writing like this. This is C point. This is E point. This is my A point. From here, I'm going to be drawing, sorry. Here, this is 4 ohms. This is 2 ohms. Right, 6.4 ohms. By looks, we can decide this is delta formation. In this circuit, this is A. You should not change this point, because from this point only you need to be measure the equivalent circuit. So this is A point. This is C point. This is E point. By looking, you can conclude directly this is delta connection. From this delta, you can modify into star, right? How you can modify into star? Like this. Right, hope you clear. After the modifying this circuit will be eliminated, right? After the modifying the circuit, this circuit will be eliminated. By eliminating the circuit means 6.5, 4 and 2 will be eliminated. The new circuit will be comes, that is delta connection, sorry, that is star connection. So for the measuring of this arm, you need to be multiply 4 into 6.5 by summation of this 4 plus 6.5 plus 2. Then you will get some value. What is the value? You will get it. You will get one value like this, 0.64. While you multiplying this 4 and 2, you will get 0.64. This value is 0.64. Then after multiplying, let me do from my side, if because some references maybe few mistakes. 6.5 into 4 divided by 12.5. Then this is 2.08, right? 2.08. What about 6.5 into 2? 6.5 into 2 divided by 12.5. That is 1.04. Right. This is 1.04. Hope you clear. Now what I'm doing now, I'm going to be insert this green. This is green part, means this is star part into the circuit. Then my circuit is look like Let me erase this. I'm not changing this A point, just I'm changing this delta into star. Now I'm inserting, now I'm inserting that green part, means star connection. So I am going to be inserting this star connection. I'm going to be inserting that star connection. Let me, so here I'm inserting that star connection over here, right? So then it will be look like, let me add this green point. This is A point, right? I'm not changing the point. This is A point already given. This is C and this is E point. Then it will, this is 1.04. This is 2.8. Now please summarize this circuit. After redrawing the circuit, you can summarize easily, and you can apply now series in parallel directly, because here if you observe this, these are look like parallel, these are look like parallel, the rest of the circuit is look like series. After coming up this series, and this is also series, hence this complete circuit is series. Then between this point and this point series, this point to this point to series, but this both are parallel. The resulting of this parallel, this is series to 0.64. Then the answer will be 0.22. Then the answer will be here. You observe this both are series, this both are series. The resulting of this series will be parallel. Sorry, the resulting of the series will be parallel. The parallel combination of this will be series to this 0.64. Then the answer will be, then my answer will be 2.21. Answer is 2.21 ohms across A and B. So this is way of solving these types of problems. Please try to solve more and more problems in star and delta transformation, delta to star transformation. Try to do more problems. On next class also we will solve a few more problems on the delta to star and star to delta transformations. So hope you understand this class. Thank you a lot. We look forward for the more problems, right? Thank you. Bye bye. Have a good day.